Right, yes, good afternoon to all. So today's class, we are going to discuss two circuits, and I'm very much confident that all the students, if you are perfect with these two circuits, entire power electronics subject, any circuit, you will be in a position to give the explanation. So I confirm that today's class, we are going to start how the current flows through the power electronics circuit, the exact implementation of the power electronics. Okay, so in previous class we have taken the MOSFET introduction, but entire subject from second, third, fourth, and fifth units we deal with the SCR, how to turn on the SCR, how to turn off the SCR, and if SCR is connected in any circuit, how the current flows. So this is what important. If you have been placed in any company, once a practical circuit is given to you, you must be in a position to give the explanation. Is the voice is audible? Anyone student confirm?
Yes, sir.
Okay, right, good, good. So, as per the syllabus, we just take the topic. The topic is the commutation of SCR in the first unit. So, commutation means the process of turning off the SCR, switching off the SCR is called the commutation. So, how we are going to commutate or turn off the SCR, we will discuss later on. But before we take the topic commutation, let us concentrate how to turn on the SCR. So in order to write any theoretical essay question with respect to the power electronics, this logic we must know. Okay. So how to turn on the SCR? If SCR is given to you practically, PNPN junction, SCR should be properly biased. So as an engineer, if a practical SCR is given to us, if somebody asking you to turn on the SCR first, why we have to turn on? In order, SCR controls the speed of the motor. In order to control the speed of the motor, SCR should be turned on. So how to turn on the SCR? I will connect the SCR directly to the plugins, it will turn on? No. SCR should be turned on means SCR should be properly biased. SCR has got anode, cathode, and gate. So what is biasing? How to turn on the SCR? When SCR is properly biased, you can see the statement. When SCR is properly biased, that is, anode is connected to positive terminal, cathode is connected to negative terminal, SCR is not turned on. Only junctions J1 and J2 are forward biased. But when the SCR is on, SCR will be on when all the three junctions are turned on or forward bias. So what is the procedure to turn on the SCR? What is the statement we have to write if any theory question is given? Explain the working principle of SCR. SCR, you can see the last line here. To turn on SCR, first bias the SCR, that is connect positive and negative terminal to the anode and cathode, and then simultaneously apply which signal? Pulse signal at which terminal? Gate terminal. You can see this is the symbol of the SCR. Here we are supposed to apply the pulse signal to the SCR. We can even apply DC triggering, application of DC, AC, but the best suited one is the pulse triggering for the SCR. So the simple question is how to turn on the SCR. In order to turn on the SCR, anode and cathode should be connected to the supply, and immediately at same instant of time, gate terminal should be connected to the pulse signal. How we generate the pulse signal? With the help of UJT firing circuit, which you have done in the earlier class. So application of UJT is not to amplify the signal. UJT is especially designed to generate the pulse signal which is applied to the gate terminal of the SCR. So once SCR is properly biased and a pulse signal is applied to the gate terminal of SCR with less voltage, only 5 to 10 volts, SCR will turn on. When SCR is on, it can control the speed of the motor. So now let us say a motor is given to you. You are asked to control the speed of the motor. So many people mention armature control method, field flux control method, which you have done on our machines. It is manually operated technique where we are supposed to use our hand, which is connected to the rheostat. But in industries, we go for automated thing where automatically the SCR is going to control the speed of the motor. So how to change the speed of the motor? By changing the gate terminal of the SCR. You can see this animation. So during it is a positive off cycle. This is the pulse signal, the blue color one. So pulse signal you can apply to the gate terminal at different angles. At 0 angle, 30 degrees, 60 degrees, 90 degrees, 120, overall up to 180 degrees. If you see the fan regulator in our house, your fan regulator is not just linear. It is in the circular motion. In the circular direction, you are going to rotate that fan regulator. So fan regulator, latest fan regulators are nothing but the power electronic devices. So where we are going to change practically the gate terminal at certain angles, 0, 30, 60. So as we change the fan regulator, we are changing practically the gate terminal. So remember one point here. So if the gate terminal is fired at minimum angle, the angle at which SCR is on is called the firing angle. The angle at which a gate terminal is given the pulse is also called the firing angle. So in simple terms, we can say the firing angle is nothing but the angle at which SCR is turned on. If the firing angle value is minimum, maximum power is transferred to the load. Remember this point. In second unit we come across this one. So when I have to turn on the when I have to apply the pulse signal to the SCR gate terminal, if you want maximum speed of the motor, you should give the pulse signal at minimum angle. If you want the minimum speed, give the pulse signal at maximum angle, let us say 120 degrees. That we'll see in the second unit. But now this concept says that how to turn on the SCR. All the students remember this point. In order to turn on the SCR, first bias the SCR and then apply the firing pulse signal to the gate terminal. Immediately SCR will be on and then motor starts to rotate. So where we use this concept, let us check the next slide here, this one. Now concentrate on this particular circuit, all of you. I'll explain the circuit. Let us say a circuit is given to you, whether it is networks or power electronics. A circuit, if at all you are observing any circuit, you must be in a position to explain the direction of the current flow. So this is one circuit. Now I am asking, yes, this circuit is given to you, explain the working of this circuit. So in what way we can explain this? Vs is DC source, how the current flows. So when the supply is on, direction of current starts from positive terminal, that is, you can see here mode 1, all of you, Vs plus. So direction of current is starting from positive terminal and that current enters which component here? SCR. SCR in the animation it is shown as T. So current enters the anode terminal of the SCR. Now anyone student tell me now SCR is on or off with this statement? Just supply is on. When supply is on, current enters the SCR terminal, anode terminal. Immediately SCR will be on? No. Okay, this is the most important point. Now at this condition, only junctions J1 and J2 are forward biased. SCR is not turned on. Immediately we have to give the pulse signal at which terminal? Gate terminal to the SCR. When a pulse signal is given to the gate terminal, if the current is flowing through the anode terminal, then SCR is on, then current flows through the SCR and then to the remaining component. That's why you see the statement here, SCR on, in brackets what we have written, UJT pulse. The meaning, examination theory points will never count. Only how circuit diagram, how the direction of current flows is very much important. So first basic circuit I have taken, we'll discuss elaborately this one. Yes, in any circuit, if you see the SCR, what is the basic explanation we have to give? When the supply is on, direction of current starts from the positive terminal. I will not dictate this one. Okay, you are in the third year now, just make a note of this one through the brain. So when the supply is on, how to explain this circuit? When the supply is on, direction of current starts from which terminal? Positive terminal or negative terminal? Current always starts from positive terminal. It is the imagination of the engineers. All engineers, they have come to one particular agreement or point that conventional current means the current which always starts to flow from positive terminal and reaches the negative terminal. We should always follow that rule. Electrons will move from negative terminal to positive terminal. But in practice, how we explain the direction of current flow? So whenever any circuit is turned on, the direction of the current starts from positive terminal, and from positive terminal to which component we are having? SCR. So current flows through the SCR. Then only junctions J1 and J2 are forward biased, but we must apply immediately pulse signal to the gate terminal. Then immediately all the three junctions are forward biased. Now SCR is on. When SCR is on, it can control any object. Now the direction of current flows from where to where? from source positive to SCR, SCR to inductor, inductor to capacitor, capacitor to the load. Load means resistive load is bulb, electric heater, water heater is resistive load, and motor is the inductive load. Right, inductive load from again load to the negative terminal of the source. So this is the first logic to explain any type of circuit throughout the power electronic circuit. So when supply is on, current flows to the SCR. SCR, once it is given with the pulse signal, then only it will be turned on, and then current flows through the different components. So why we are placing inductor and capacitor, we'll discuss. We'll come to that circuit. So first, today's class, the first introduction is, as per the syllabus, the topic is commutation of SCR. How commutation means the process of turning off the SCR, and what are the different methods you are using to turn off the SCR. You can also say, sir, why we require the methods? I'll switch off the supply, SCR will be off. No, SCR is connected to the motor and different components. Directly we cannot turn on. If you turn on the supply, entire system will be off. You are supposed to turn off only the SCR. So how to turn off the SCR, we got techniques. So first we are discussing how to turn on. So how to turn on the SCR? SCR should be biased and apply the UJT signal. Then we confirm that SCR is on. This is the statement regarding this one, what we have discussed just now. Right. Okay. So we got the circuit. Now we concentrate on the word commutation, commutation of the SCR. Okay. So how to turn off the SCR? So in order to understand how to turn off the SCR, we must observe how the current flows for this particular circuit, how the current flows. Right. Let us take a basic circuit where we are having the capacitor. So inductor and capacitors will present throughout the circuit. We'll discuss elaborately. So when supply is turned on in any circuit, what is the assumption we have to create? In what way we have to understand the power electronic circuit? Every circuit will contain the capacitor. So when you turn on the supply, okay, first current flows through the capacitor. Capacitor charges and starts to discharge. This capacitor cannot store the energy permanently. It stores the energy only for short period of time. Okay, right. So that's why we cannot save the electric energy in our houses. Okay, we got no electronic device to store the energy. Capacitors, inductors store energy only for short duration. So you can see when supply is on, first capacitor starts to charge. Simultaneously, certain power will be transmitted to the load, and after certain period of time, capacitor starts to discharge. But what point we have to concentrate here? What is the direction? Yes, you can see the positive and negative. Okay, upper plate is positive, lower plate is negative when capacitor is charging. When capacitor is discharging also, the plate, upper plate will be positive, lower plate will be negative. You will see this one. This is important in our subject because we have to explain how the current flows. When capacitor is discharging, now the capacitor starts to discharge. You can see from where the direction of current flow is started, from the positive terminal through the load, and that energy has to come back to the negative terminal of the capacitor. In this way, we have to design the circuits. The capacitor has to charge, discharge. Let us say I'm giving you one motor. Run the motor when the power supply is off. Can you do that one? Yes. In parallel with the motor, we will place the capacitor. When supply is on, capacitor stores energy. When supply is off, capacitor releases the energy. Only for short duration, we can run the motor. Now, okay. How to turn on SCR we have done. Now we concentrate commutation. So the topic is, what are the different methods of commutation of SCR? Okay. As all students, this first line is visible. Disadvantage of gate terminal of SCR. Visible to all? You can see this line. Okay, right, good. So what is commutation? Process of turning off the SCR. Okay. So why we have to turn off the SCR? Because in order to stop the motor or in order to stop the load, we should first stop the electronic device. So we got different methods to turn off the SCR. So what is this first line is indicating? The disadvantage of gate terminal. Gate terminal is used to turn on the SCR but cannot be turned off the SCR, cannot be used to turn off the SCR. So yesterday I mentioned why we are using IGBT, why we are using MOSFET, because SCR has got one disadvantage. SCR cannot turn off itself and it requires complicated circuit to turn off. Okay, so SCRs are not used practically in the inverters. But throughout the subject, we are not having only inverters, we are having different circuits where SCR is practically used. So here disadvantage of gate terminal is gate cannot turn off the SCR. So what is the commutation and what are the commutation methods? How many commutation methods we are having? So first, how many types of commutation are present? One is natural commutation and forced commutation. Natural commutation in the sense is what? It works with AC supply. If the here we have written the statement, if the input is AC supply, SCR turns off automatically whenever the input cycle changes at 180 degrees, 360. As we know, AC supply contains positive and negative, and that positive pulse and negative pulse goes on changing. At one particular point, at 180 degrees, what is the value of input AC voltage? Well, 0. You can see in the picture here. And here also it is 0. Therefore, if input is AC, there is no need to purchase any external circuit to turn off the SCR. It is natural commutation. If SCR is turned off with the help of external circuit, then that type of commutation is called forced commutation. So forced commutation we come across when the supply is DC. You can see here DC source. DC cannot change, it is a constant source. Once it is 5 volts, it will be 5 volts. So how to turn off the SCR? In order to turn off the SCR, supply will be constant. We design new type of circuits which are called the commutation circuit. These circuits contain inductor and capacitor, and these circuits, they are used to turn off the SCR. So in first unit, they are mentioned, explain the definition of the commutation, what are the different types of commutation, natural and forced commutation, and what are the different circuits developed to switch off the SCR. That is, what are the different commutation circuits. So first commutation circuit we are taking, which is load commutation. Otherwise, another name is called class A. So this examination also they will ask you define commutation, explain different methods of commutation, different methods. So first method is class A commutation or load commutation. Why the name load? Because the commutating elements, the elements which are used to turn off the SCR are called commutating elements. What are commutating elements? Tell me. Inductor, capacitor, or diode. Okay, and this combination will increase. So as it is a first unit, the basic circuit we are discussing, the commutating elements are inductor and capacitor. These commutating elements are placed in series with the load. That's why it is called the load commutation. Okay, or series load commutation. Okay, so this is a basic circuit. So we'll explain this circuit now. But before we explain, before we study how to turn on and turn off, in this circuit we are going to explain what is class A commutation means. We explain how SCR is on and how we are turning off the SCR. That logic we require actually. It is a tough topic, but we should explain, we should concentrate here because the entire core of power electronics logic is based in this particular circuit. So in order to explain this one, the practical approach. So what is load commutation circuit? Load commutation circuit contains commutating components which are placed in series with the load. What are commutating elements? Inductor and capacitor are called commutating elements because these elements are responsible to turn off the SCR. So which elements are used to turn off the SCR? We can use basically inductor and capacitor. Okay, let us, in order to understand this one, we should study the definition of latching current and holding current. So in working principle, I forgot to explain that one. So let us go back to this graph. Okay. So if you observe this graph, we have discussed the forward conducting state. You can observe here IH and IL. What is latching current? The minimum current, both are minimum currents values only. Minimum current required to keep the SCR in on state. So when we can confirm that SCR is on, when all the junctions are forward biased and certain amount of current is flowing through the SCR. What is that current name? Actually, at that particular period of time, we confirm that when the SCR is on, if all the three junctions are turned on, then the current is called the latching current. So the minimum current value required to keep the SCR in on state is called latching current. So in the graph they have mentioned latching current below which it will turn off. One more current. What is holding current? Minimum current below which SCR turns off. So this is very important, all of you. Holding current definition. You can see your holding current appearance is given here. So if I want to turn off the SCR, remember this logic. This is not mentioned in any textbooks. I can say confidently what is the technique to turn off the SCR. The technique to turn off the SCR is first study the definition of holding current. Holding current says that it is the minimum current below which SCR turns off. So if you want to turn off an SCR, send the current and make the holding current make that particular current very less. That is, the minimum current below which SCR turns off is called the holding current. Now we discuss this logic. Now what is this note point we have mentioned? In any circuit, how to turn on the SCR? SCR should be properly biased and apply the pulse signal. Okay, that part is done. Now, how to turn off the SCR? This is the most important question. How you are going to turn off? People mention, okay, I'm using the commutating circuits. But what is the logic to turn off the SCR? We have written here clearly, in order to turn off the SCR, now this statement is important. Pass the current through cathode terminal. As is you can mention in the examination when you are explaining the commutating circuit. Only certain technical lines, technical points and circuit direction, circuit representation, direction of current flow is very important. Now, how to turn off the SCR? In order to turn off the SCR, pass the current through which terminal? We should design the circuit in such a way that current should enter in which terminal? Cathode terminal. Okay, so if I want to turn off the SCR, I should design the circuit in such a way that current is first entering into which terminal? Anode? No. In order to turn off the SCR, current should enter the cathode terminal first. Okay, if the current enters the cathode terminal, immediately SCR will be on, off? No. Once the current enters the cathode terminal, that current value should be greater than holding current. Then only SCR will be off. You see the second line? If the current value flowing through the cathode is decreased and made less than the holding current, then SCR turns off. So you see what is holding current definition? If you want to turn off the SCR, what we have to do? Minimum current below which SCR turns off. You should send the current through the SCR to the cathode terminal, and that current should be greater than the holding current. Remember this point. Here it is written in reverse manner. This particular. So definition is minimum current below which SCR turns off. Okay. So what is the logic? In order to turn off the SCR, send the current through the cathode terminal. We'll come back to this one now. Yes. Now we are discussing the topic. So today's class, what are the crucial points we have taken? How to turn on the SCR and what is commutation? Process of turning off the SCR and what are the different commutation methods? First method we are discussing. We are starting now. Load commutation, class A commutation. You must draw the circuit. This circuit in the examination, I'll explain the graph also. Right. So why this circuit is in this manner? So this load commutation represents the circuit contains load commutating components which are placed in series with the load. Commutating components are used to turn off the SCR. Now we start the explanation. When the supply is on, mode 1, we have to start with the mode 1. When the supply is on, direction of current starts at the positive terminal. So current flows from positive terminal Vs plus to SCR, SCR to inductor, inductor to capacitor, capacitor to load, and load to back to the source. During this process, what will happen to the capacitor? Capacitor charges. Now you can ask one question, sir, why you are not mentioning the inductor energizing and de-energizing? So here the point which is not mentioned in the textbook, if you see maximum circuits contain inductor and capacitor, the inductor operation will be very much slow when compared with the capacitor. If you are designing the circuits only with inductor, the circuits will take maximum time to turn on and turn off. So inductor stores energy in the form of magnetic field, capacitor stores energy in the form of electric field. But capacitor charging and discharging is very fast when compared with the inductor. So many textbooks, even if you find the inductor, they give the explanation with respect to the capacitor. That means temporarily the energy storage details of the inductor we are neglecting in our explanation. That's why inductor current flowing through the inductor is mentioned, but what is energy transfer is not mentioned anywhere. So directly you can mention in the examination also, practical approach also. When the supply is on, direction of the current starts from Vs plus to SCR, SCR to inductor, inductor to capacitor, capacitor starts charging. So what is the terminal upper plate? Anyone tell me? Unmute and you can tell me. Upper plate is positive or negative? Upper plate will be
Positive.
positive. Very good. Because capacitor current is entering the upper plate first. Therefore, upper plate will be positive, and then current flows through the negative plate and then to the load. So here I forgot to mention C plus and C minus. It doesn't matter. You can use directly C. So in this way, current flows through the circuit, and the current also flows through the load. And if the load is bulb, bulb will be on. And if the load is motor, motor starts to rotate. Okay, how to turn on we have explained in the first stage. Okay, and now second stage of explanation. Second stage of explanation is how we are going to turn off. This is important. So make sure that you are understanding this concept here. So how the capacitor discharges? You see mode 2. What is our target? To turn off the SCR. So capacitor starts to discharge. So what will happen once the capacitor is charged to maximum value? Capacitor contains internal storage also. So capacitor voltage will be greater than the supply voltage. If I am applying 5 volts, capacitor will be charged to the 5 volts plus internal capacitor voltage by default will be 0.2 or 0.3. So total 5.3 volts will be present across the capacitor. So capacitor, once it is fully charged, so energy will travel from capacitor to the source. Therefore, capacitor starts to discharge. Now, I hope all students have seen that animation. Now you tell me from which plate the capacitor starts to discharge, upper plate or lower plate, positive plate or negative plate? It is
Upper plate.
100%. Very good, very good. It is 100% upper plate positive only. That is what we have to confirm here. If it is inductor, it gets reverse. Okay. So that's why I've shown that animation. So now what is the discharging path? How the capacitor discharges? Why the capacitor has to discharge? When capacitor discharges, the SCR will turn off. Then we can happily turn off the motor. Now you see how the current flows here. Capacitor positive plate to inductor. I mentioned here discharging. Discharging path of current is from C plus to inductor. Already I mentioned inductor operation is skipped in all the textbooks, and in our explanation also. We are not explaining how the inductor energizes and de-energizes. That we'll see in the later part in the second and third unit. So here capacitor discharges. Discharging current starts from the positive plate of the capacitor and it moves to the inductor. From inductor it flows through the SCR in this direction. SCR, which terminal it is entering now? Anyone student? SCR, which terminal the current enters first now? Cathode terminal. So you must design the circuits in such a way that in order to turn off the SCR, send or pass the current towards the cathode terminal. So when capacitor discharges, current flows from C plus to inductor, inductor to SCR, that to cathode terminal. Now immediately SCR will be off? No. If the current, yes, current flows through the SCR, and then current also flows from SCR to source, from source to the load, and from load to C minus, negative plate of the SCR. Many people will get one doubt, sir. Current is entering the SCR, cathode terminal. SCR will turn off. When SCR is off, it is open. No current can flow. No, that's why you must see this last point. What we have written? As when discharging current is greater than holding current, SCR turns off. So when capacitor starts to discharge, the discharging current will be less than holding current of SCR. But when the SCR will be off, when discharging current is greater than the holding current of SCR. So when capacitor starts to discharge, current flows from C plus to inductor, inductor to SCR. Now this current cannot turn off the SCR because it is less than holding current. So when that current can turn off the SCR? When it is greater than the holding current. So current flows from SCR to source. And so why current is going towards the source? Because capacitor voltage is higher than the source voltage now. Okay, energy travels from high level to low level. So now the current flows through the source, from source to the load, and from the load it comes back to the C minus. In this way, we discharge this particular, we turn off this particular SCR. Okay, this graph will explain in the later stages, not now, only the circuit. Now I'm giving one circuit now, all of you. Okay, I'll see who will explain this one. You take the snapshot, you try at home, don't see any textbook. Now only I will tell. So explain this circuit. We got 5 minutes time. Let us move fast for this one. Okay, so I'm just putting out here, all of you. If anybody can explain, explain me. What is mode 1? Always mode 1, how to turn on the SCR. Yes, tell me. When the supply is on, current flows from VDC plus to where it will flow? It will flow through the SCR. We are giving firing pulse to SCR. SCR is on. Current flows through the load, from load to the negative terminal. And at same instant of time, remaining amount of current flow also flows through the capacitor and inductor. They get charged. So what is the first part here? Current flow. VDC. VDC, I'm writing directly. Source to SCR. Okay, put caps lock. Source to SCR, SCR to the load, and from load to the source. Okay, simultaneously at same instant of time in mode 1 only, current also flows. What is the next part? Current flows from source to capacitor, capacitor to inductor, and from inductor to the load, and from load to the VDC minus. Understood all of you? In any circuit, how the current flows. So when supply is on, current flows through the SCR and to the back to the from the load to the source, and remaining amount of current flows through the inductor and capacitor, where they start to store the energy. Now when we are having inductor and capacitor in series, we take the explanation, we take the behavior of the capacitor, how it is charging and discharging, because capacitor operation is fast when compared with the inductor. So why inductor is skipped, we will see in the later on stages, but this is the explanation. Now tell me mode 2, anyone. I'll give 1000 rupees cash prize for this one. Mode 2, what should be the explanation? Think and tell me. Right. Mode 1, any circuit throughout the subject is all about turning on the SCR. Okay. Now, no, mode 2 is what? How to turn off the SCR. Now you tell me. In order to turn on SCR, capacitor starts to discharge. Capacitor starts to discharge. How it will discharge? It will discharge from its positive plate only. Okay. So capacitor starts to discharge. Then what will happen? Where the current flows? Think all of you. Okay. So next class, when we start the explanation, we start with this circuit, how the current flows and how the capacitor starts to discharge. I'm giving the time because only 2 minutes is left for this one. Right. So mode 1, how we are turning on the SCR, and mode 2, how we are turning off the SCR. That is a basic circuit introduction. So next class we take this circuit and we just move on to the fully controlled converter. Now let me share. First I'll take the attendance here. 1 second, let us take the screenshot. 21 participants are there. In chat box also simultaneously put your details. Only 13 students have mentioned the details in chat box. Okay, you think regarding this one? Let us check the syllabus. Yes. See, first unit, concept of power electronics. First class we have taken the what is the concept? We control the motors and the load. So applications. Okay. And next, types of power converters. Yes, today we'll do this one, types of power converters. Okay, different topics we got. 1 second. Yes, last 1 minute is present. Now there is small quiz for you all people. This circuit, how to explain, we'll take in the next class. Direction of current flow. Tell me, all the students, okay? Take it as challenge. You have done with the diploma. What is the name of this first circuit? We got the topic names, types of converters. How many types of converters? Anyone name me the first circuit? What is the name? Only one SCR is present. 5 seconds time. 1, 2, 3, 4, 5. All are present or not? So this is off wave right, good rectifier converter, off wave. This is, it provides discontinuous current. It is not used practically. Now come to the second one. Anyone, come on. How many SCRs? 4 SCRs. What is the name of this circuit? Full wave converter. Full wave converter. Good. Yes, this circuit is used. Where it is used? Speed control. It provides speed control in okay, here it is full wave. Sorry, here I have written this explanation should be here. All of you, explanation. Full converter is used for speed control of motor in both directions, forward movement and backward movement. Imagine electric train has to move forward direction, backward direction. There we use. Now come on, this one, anyone? This is challenging. What is the name of this one? Last. Okay, I will tell. It is semi converter. 2